Hello class. Hello class. Our topic for today is fluorimetry, and this is the fluorescence spectroscopy. This is how the machine looks like. So we're going to teach you, explain to you how the machine is from the inside, what happens with the sample, and how the analysis occur. We're going to introduce his introduction, the definition, and the theory, the principles of fluorimetry. Now, luminescence. Luminescence is the emission of light by a substance. When electrons of a particular molecules are on the ground state and certain amount of light falls on that molecule, some electrons will go to the excited state, which make them unstable. And for them to become stable, they return to their ground state. On coming to the ground state, they emit certain amount of energy. This certain energy that is emitted in the form of light, which is this phenomena as a whole is known as luminescence. There are three types of um, luminescence: fluorescence spectroscopy, phosphorescence spectroscopy, and chemiluminescence spectroscopy. Fluorescence. In fluorimetry, a sample is exposed to light source of a particular wavelength known as excitation wavelength. When the sample absorbs the photon from the excitation light, it goes to a higher energy state. This state is usually short-lived, and the sample returns to its original state by emitting light at a longer wavelength known as the emission wavelength. Now, the emitted light is then measured using a detector, such as photomultiplier tube. The intensity of the light emitted is proportional to the concentration of the fluorescent substance in the sample. Fluorescence is the emission of visible light by a substance that has absorbed light of a different wavelength. The emitted proton, as I said, has a longer wavelength. Phosphorescence is related to fluorescence. Well, phosphorescence um, is related to fluorescence in emitting a photon. However, a phosphorescent material does not immediately re-emit the radiation it absorbs, as the excitation of the molecules is due to the absorption of a photon, that is the light. This type of luminescence are called photoluminescence. Well, in fluorescence, when light radiation is um, is incident on a certain substance, they emit light continuously even after the incident light is cut off. This type of delayed fluorescence is called phosphorescence. In this case, the emitted light is in the range of ultraviolet radiation. In the fluorescence, the emitted light is in the range of visible radiation. The substance showing phosphorescence as phosphorescent substance, and the time required for compound to show phosphorescence is 10 to the power of minus 4 to 20 seconds. This is the general layout of the fluorimetry. Now here, this is the power source. This is the power supply, this is the source of the power, and this is the primary filter. This is also called the monochromatous. This is the sample cell where you put your sample inside a sample will be in a cuvette in a sample cell inside the machine. Then this is the secondary filter is also a monochromator. This is the detector, and this is where your data is being processed. This is the photomultiplier tube. The detector photomultiplier tube is one of type of the detectors. As you can see, it is always placed, as you can see, it's always in a 90 degrees. the sample is always placed in the 90 degrees of the filters. The primary filter comes first, then the secondary filter. We're not going to talk much about the chemiluminescence, but in this process is another phenomenon that falls in the category of luminescence. This refers to the emission of radiation during a chemical equation. For example, in such cases, the excited state is not as a result of absorption of electromagnetic radiation, meaning it's not the absorption of light radiation. The oxidation, for example, the oxidation of luminol in alkaline solution is an example of chemiluminescence. It emits light, this process. Light was not absorbed, but it emits light. Let's understand some terms. We all know that electrons present in an atom have a specific spin associated with them. These electrons pair themselves with electrons having spins opposite to theirs. As a result, the net spin of the pair of electrons is zero. For instance, this. Electrons of a particular molecules are on the ground state. Now, certain amount of light, they absorb certain amount of light and becomes excited and graduate from lower energy level to higher energy level. In that higher energy level, they are not stable. They undergo some vibrational energy. They emit some. A lot of processes happen in that place where you have explained later. Then they return. They return to the ground state where they will be stable. So on returning to the ground state, they emit fluorescent light. While in the phosphorescence, there is a delay before they then return back to the ground state. They lose small amount of energy, they come back to the triplet excited state, then they go back to the ground state, emitting phosphorescent light. Know that we know that molecules contain electrons. The electrons may be present in bonding molecular orbit. It is called as the highest occupied molecular orbit, HOMO. Highest H, occupied O, molecular M, orbit O. It has the least energy and it is more stable. That is the ground state, as I have been explaining, the ground state. When these molecules absorb radiation from a light source, the bonding electron become promoted, they become anti-bonding, hence they move to a more energy level, which makes them unstable. That is the singlet excited state. That is the LUMO orbit, LUMO orbit. As you can see, one going anti-clockwise and one going clockwise. The one going in clockwise direction is negative half, and the spin in the anti-clockwise direction is a positive half. Combine them, you get zero. However, certain spin, so when these electrons are paired with electrons having opposite spin, they are said to be in a singlet state. However, certain times arises when both the paired electrons have same spin associated with them. As such, this is called a triplet state. What happens in a ground state is that whenever the electrons they are present, whenever the electrons present in a molecule, they are present, they are always present in a paired form. Now this state, as we said, is a singlet state. Now when paired electron absorb UV or visible radiation, one or more of the electron go to the excited singlet state or excited triplet state. The process of promotion of electrons from HUMO to LUMO with absorption of energy is called excitation. There is another state known as the doublet state. This is a state in which there is two unpaired electrons. Either one is going up, the other is going down. These unpaired electrons are said to have an opposite spin. They are all single. That is a doublet state. Now, a triplet state is a state in which the unpaired electrons are having the same spin. So, excited state is having either singlet state or the triplet state. The singlet state is having higher energy while the triplet state is having lower energy. Singlet excited state is a state in which electrons are unpaired but the opposite spin, like unpaired and opposite spin. So when they from ground state, this is the ground state, they absorb light from here and they move to higher energy level. So from here, they, because they are unstable, they lose a lot of electron and they come back to the ground state. On coming back, they emit light. So when they emit light, it's either in the UV region or in the visible region. That is how you know whether it is fluorescence or phosphorescence. See here, this. So now when a molecule absorbs this light and is being promoted from a singlet ground state to an singlet excited state, once this molecule is in this excited state, the relaxation occur in various processes. By emission of, for example, by emission of radiation, these processes happen, as I've been explained earlier. Vibrational relaxation also happen, internal conversion, external conversion, intersystem crossing, all happen after when they reach that excited state before they come back to the ground state for them to become more stable. Stable. Here, this is a Jablonski diagram, energy diagram, showing you the ground state, the energy level 1, S0, 1, 2, 3, 4, 5, where it gets excited. From here, it executes vibrational energy in this energy level 2. It loses small amount of energy and then it comes back to energy level 1, undergo interversional conversional transmission, whereby from there it goes back to its ground state, emitting light, fluorescent light or phosphorescent light. When there is delay of fluorescence, you get phosphorescent, and it falls within the ultraviolet region. The entire energy loss is due to collision deactivation. That means no radiation is being emitted. Now, in the fluorescence, I explained a relaxation of electrons from excited singlet to excited ground state with emission of light. That is fluorescence. When they are excited, they are highly unstable, so how they have to return back to their ground state. On returning back, they emit fluorescence. While phosphorescence, they at favorable condition with a low temperature and absence of oxygen, there is transmission from excited singlet state to triplet state, which is called the inner system crossing. The emission of the radiation when electrons undergo transmission from triplet state to the ground state is called the fluorescence. Understanding the principle of fluorimetry. Here, to understand this principle, we need to use this graph. Now, using this graph, here is the ground state. This is the ground state. This is the ground state, which consists of certain discrete energy level 1, 2, 3, 4, 5, and so on. So all the electrons that are present in the molecule are in the ground state. In this ground state, all the electrons are in the singlet state. That is, all the electrons are unpaired. Now, suppose some amount of radiation fall on that molecules that are on the ground state. From that, they become excited and go to the higher energy level. energy state. In this state, we know that the spin of the electrons are opposite to each other in this state. But in this state, the electrons are not stable, so interconversion will take place and they emit very small amount of energy and they come to the lower energy level. They come to another lower energy level. On coming to this lower energy level, lower than the singlet excited state, is a little bit lower than the singlet excited state. Then from this triplet state, the electrons come back to the ground state level. Here, they come back to the ground state, emitting, when on coming back, they emit certain amount of radiation, certain amount of energy, and that energy is emitted in the form of light. This is the emitting the fluorescence. When this light falls in the visible region, then the particular phenomena is called fluorescence. And when it falls in the ultraviolet region, the particular phenomena is called phosphorescence. So this is just the principle of uh, fluorimetry. See, this is the, when it is around this area, it is the what visible region here. This is the ultraviolet region. So hope you understand. This is the Jablonski diagram showing the phenomena of fluorescence and phosphorescence as I explained earlier. This is the excited singlet. As you can see, the ground state from here. The ground state absorbs energy. It goes up to this state, this energy level S2. From here, it loses small amount of energy. It comes to energy level S1 where it undergo internal conversion. Still, we are still in the singlet excited state. Here in the S1, it undergo vibrational relaxation where it then return to the ground state at the where it emits, on coming back to the ground state, it emits fluorescent light in the visible region, while there is another inter-system crossing where it then go back from here, from the S1 energy level, it undergo inter-system crossing, it goes to T1 energy level, whereby the triplet excited state energy level. From here, the triplet excited state, it then emits, it's still not stable, it then go back to the ground state, emitting phosphorescence, in the process emitting light in the form of phosphorescence, the ground state, making it more stable. And under phosphorescence occur in this region will be in the UV region, while fluorescence is in the visible region. As I Fluorescence and chemical structures. Fluorescence is most commonly observed in compounds containing aromatic functional group with low energy. Now, the presence of benzene ring and the nature of substituent on it seems to favor the fluorescent behavior of the molecule. The halogen substituents tend to decrease the fluorescence and shift the fluorescence band to longer wavelength. The effects increase with increase in the atomic mass of the substituted halogen. Most unsubstituted aromatic hydrocarbons shows fluorescence. Quantum efficiency increases with the number of rings and degree of condensation. Simple heterocyclic compounds do not exhibit fluorescence. For example, pyridine, furan, thiophene, pyrrole. While fusion of heterocyclic compounds, heterocyclic nucleus of benzene ring increases fluorescence. Compounds with fused ring are found to be especially fluorescent, and the extent of fluorescence is found to be directly proportional to the number of rings in the molecule. The structural rigidity in a molecule favors fluorescence. And one of the example is phenolphthalein. Phenolphthalein has conjugated rings, have a lot of benzene ring associated, fused rings with them. Fluorescence observed with rigid cyclic molecules with pi bonds is found to be enhanced by electron donating groups, e.g. NH2, OH, and so on. Aliphatic and alicyclic carbonyl compounds or highly conjugated double bond structures also show fluorescence. Substitution on the benzene ring sheath wavelength of absorption maxima at corresponding changes in fluorescence peak. Electron withdrawing groups such as COOH, NO3, NO2, nitro, azo group, um, bromide, iodide tend to reduce the fluorescence peak. The fluorescence decreases with increasing atomic number of the halogen as well. So now, on the other hand, the non-rigid molecules do not fluorescence much, as this rapidly loses the absorbed energy through non-radiative means like vibrational relaxation or even degradation. Rigid compounds, they tend to have increased fluorescence. Fluorescence is favored in molecules with this type of rigidity. Organic chelating agent complexed with metal ions increases fluorescence. Thank you for watching. Don't forget to subscribe, like, and comment.